Hello, my name is Sean and I work on the engineering side at Informal. This quarter, a lot of our focus has been on the light clients. So the light client is our protocol for verifying application state without downloading full blocks. It's pretty important that we get our light client running, as it is a key component of IBC. So some of the work that we did this quarter involved supporting multiple peers and a new kind of concurrency design. So we have this problem that the light client is potentially going to be used by multiple components. So it needs to function not just as a standalone executable, but sort of like in an embedded capacity. So what we do is we launch it in its own thread and provide sort of read-only access by channels to external components. One of which is going to be the relayer as part of the larger IBC effort. Some other work that we did this quarter was adding support for multiple peers. So instead of initializing with a single trusted state and then a primary full node that it could download off of, we now parameterize it with a set of witnesses. And this sort of witnesses can essentially download the same header multiple times from multiple peers and then compare the values in a sort of like fork detection algorithm. Beyond that, we worked extensively on not just the code, but on fleshing out the spec, both in English and in TLA, and providing sort of runtime verification facilities to the core protocol logic in the code with traceability between the spec and the code. So if you were to go through our implementation in Rust, you'll see a bunch of indexes of the invariants which are asserted at runtime through this sort of precondition system that we've been experimenting with. And the idea there is that even though this constitutes like an initial release, so obviously the light client is under heavy development and there'll be many more iterations, that we could use the runtime verification facilities to maintain alignment between the software artifact and the spec. So coming up next in the next release, which is probably going to be at the end of July, we could very much look forward to adding more concurrency to the fork detection protocol. We're going to start looking at making our structs more generic. That will allow us to manage upgrades to Tendermint a lot easier and start integrating some more people into the project using model-based testing. So we're building a tool, have started using it, but we'll definitely use it in the next release to essentially generate complex types, right? And our dependency graph. So for instance, like validator sets are represented as hashes. So there's like a relationship between these fields. And then for different test cases, we need to sort of generate different kinds of validator sets, which can be quite cumbersome. So we're actually developing a tool that will make the generation of our complex types a lot easier, which will make unit testing a lot easier, which will make the software much more secure. So that's some of the stuff that we're very much looking forward to in the next release at the end of July of the light client.
Hello, I'm Adi. So I'm part of the IBC team. The biggest release we had in this quarter, the biggest part or the biggest update of this quarter was the fact that we had our first release. So we had 001 for IBC RS. I guess the cool things that are part of this is that we have some basic functionality. So there are 3 modules that are part of this, or 3 crates that are part of this project. There's the relayer, there's the command line interface of the relayer, and then we have the IBC modules. The IBC modules comprises some common parts that the relayer is using, and the basic functionality that you can find and that you can play with from this first release is in the relayer. So you can start the relayer, you can interact with it from the command line interface, and you can start some queries against the Cosmos hub. The queries, most of them will fail because of encoding issues, but we have most of that functionality, or some code around that functionality. It's written already. We also have functionality for the relayer to monitor basically a chain and to keep up to date with the height of that chain. And these are perhaps the biggest things that we have in 001.
My name is Elena, and I'm a research engineer at Informal Systems. During the past few months, I've been working on the IBC project, where I have contributed by writing TLA plus specifications for the IBC layer. Our goal in the IBIS project is to formally specify and verify the IBC-related protocol. So far, we have been working on formal specification of the IBC layer and the connection handshake protocol. To formally specify and verify these protocols, we use the specification language TLA+, which is a specification language developed by Leslie Lampert and which is widely used for specifying and verifying distributed systems. So the specifications that we produced for the IBC layer and the connection handshake are modular in the sense that the different components the logic for the different components is specified separately. And we've been also able to verify several safety and liveness properties of these protocols for where the heights of the chains are bounded by a small constant. And even for these relatively small heights, the state space that the model checker has to explore is quite large, and it takes the model checker quite some time to verify the properties. So the challenges that we're facing and we're trying to address in the future is how to come up with the right abstractions for complex systems such as the IBC layer and the connection handshake protocol in order to make their specification verifiable with existing tools. And this is what we're hoping to achieve in the future.
Hi, my name is Igor Konov. I'm working on the Apalache model checker. And in this quarter, we actually had several interesting things happened. We have prepared the release 070 of Apalache, which includes a lot of improvements to the model checker. We fixed a few bugs people were asking about. Then we also worked on the integration of Apalache with a TLA toolbox. You cannot run Apalache from toolbox now, but you can read the TLC configuration files in Apalache. You can export Apalache counterexamples to the TLC format. And we also worked a bit on the integration between Apalache and JSON format. So you can import now TLA specifications from JSON, export them to JSON, and that might be helpful to writing some third-party tools, for instance. What else? We also had some improvements for cardinalities in Apalache. For some cases now, the translation is much more efficient. You can check the properties faster. So apart from that, we also had some results on type inference now. We are going to implement a new engine for the type inference in the next couple of months. We actually have this engine, we just have to integrate it into Apalache, and hopefully this will free the users from the need to write type annotations for the tool. That should be completely automatic. So we are very excited about that. But it's not in the current release, it's going to be in the next release. And finally, we have one more person working on the project now. Sean Federer has joined the team recently. So in total, we have now 4 people working on the project, including Yura Kukovets, Sean Federer, and Andrei Kupriyanov, and myself. So we are very excited about what will happen in the next quarter.
Up to this point, the focus of the plain text tooling team has been on improving the management of distributed organizations through the use of open source development methodologies and plain text-based tools. Our purview has included contracting, document management and automation, grants management and processing, project management generally, and developer tooling. Here are some of the highlights of the work that we've gotten done over the last quarter. We developed a tool called Famous Grants, which is a web app that can be used to navigate grants stored in GitLab projects, pulling the entire GitLab group down locally and reflecting that structure, allowing us to browse and search through it. We developed Layla, which is a tool for pulling documents and artifacts out of cloud-based sort of walled gardens and making them available locally, and most importantly, tracking it all and entering it into Git repositories. We rewrote the famous contract product in Go from TypeScript for version 2 prototype, brings a lot of improvements. Famous contract enables modular and parameterized contracting and also tracks change and negotiation history in Git. We're going to continue developing and maintaining Famous Contract through the rest of the year. Finally, in collaboration with our principal scientists, we made significant progress on the design and specification of Famous Tracer. Famous Tracer is a software requirements management tool designed to meet the needs of informal systems verification-driven development, but with wide applicability. In essence, it lets you trace through specifications and design requirements all the way from informal natural language specifications to the sites of implementation in the code. We plan for a version 0.1 to be completed and an internal use on the IBC work early this year. So we can say a few words about what we learned. At the end of the last quarter, our team understood its mission to be focused on improving business operations and organization management pretty narrowly. This still falls under our purview, but our ongoing research and reflection revealed a sort of a more general and less implementation-bound understanding of what we're after. We can summarize that in 3 points. So we're trying to empower communities to refine their informal and open-ended communication and refine it into executable programs and machine-readable configurations which will multiply the power of the organizations, and ultimately refine these further into contracts and proofs that secure the rights and guarantee the properties of these organizations through interactions with other organizations. At the close of the quarter, our improved understanding and developing business model conspired to induce a transition in our focus. So it's now clear that the previous focus on corporations and contracts, while still relevant to our mission, is a specific case of the more fundamental concern with inter and intra-organizational relationships, and especially with the methods for verifying and guaranteeing these relationships. This now appears to be more a matter of concern for with protocols and proofs generally. The concrete result of these realizations is a reduced but not eliminated focus on business operations and a turn towards embedded support for the development and verification of IBC.
Hi, I'm Žarko. I'm Chief Scientist at Informal. I will give you a quick overview of the research projects we are involved with partners, worldwide research institutions. We have projects in distributed system space and formal verification space. On the distributed system side, we are collaborating with the Professor Pedone group from Lugano, and we are working on improving the gossip architecture for consensus protocols, like Tendermint. We also collaborate with Professor Gerowi group from EPFL on improving Tendermint fork accountability protocol and making it also usable for other consensus-based systems. On a verification side, we collaborate with Professor Kunchak from EPFL on verifying the like-line implementation in Scala using the stainless tool they developed. We also started at the baby step on verifying the Rust implementations. We also collaborate with Giuliano Loscia from Galois on formally verifying attacks in the context of fork accountability protocol, and also formally specifying and verifying Tendermint protocol with the fork accountability in IBI for unbounded number of processes. We also collaborate with Professor Zulager from TU Vienna, Mariana Lazic from TU Munich, and Natalie Bertrand from INRIA on formally verifying consensus protocols. All those projects are ongoing for quite some time, but in last quarter, they materialized in a lot of publications, more than 10 publications, some of them accepted already in top venues, and some are under submission. And we hope to make them public very soon.